Hi. Our lesson for today is what we call TCPIP basics. What we currently have here are the lessons that I will impart to you would be uh, routing. Matututunan natin ang routing for today. Um, how does the information like from let's say host A to host B, okay, and their we have a geographic span between those two devices. Okay, paano nakakarating yung information natin from point A to point B. Okay, using routing. Okay, so the first thing that we would like to talk about this basic routing process. Okay, is um, okay. How are we able to reach? Okay, if you'll be able to notice here, how are we able to pakikita natin dito si um, A, si 192.168.1.2, how will it be able to reach the server from the other end here? Okay, so yan ang gusto nating malaman. If you'll be able to notice, we currently have the common setup, one switch, right? One router, okay, and then it goes to another router, to the switch, and to the host address. But the main question that we have is that how does a packet from source IP address of 192.168.1.2 get routed to a destination IP address of 192.168.2.2? Basically, yung mga routers natin, we currently have what we call the routing table. So, yung router natin, may kailangan siyang puntahan, kinoconsult niya yung kanyang routing table. Hahanapin niya yung pinaka magandang match para doon. Tapos, doon niya yun i-route. Okay. What if you have multiple entries sa routing table mo? The longest match, okay, the best match is the route that has the longest prefix. So, for example, you currently have two entries for 192.168.1.0. Let's say the other entry is 192.168.1.0/24, whereas the other entry is 192.168.1.0/25. Okay? Papunta ka sa 192.168.1.1. So what would be preferred would be the one that has the /25 entry. Yun ang best match natin. Okay? It has the longer prefix versus dun sa /24. And of course, a route entry with the longest prefix is the most specific network. Also, meron tayong ARP. Okay? So, yung ARP na yan, nandyan yung layer 3 to layer 2 mapping natin ng information. So, if you'll be able to notice here, yan yung ARP ng ating router. Okay? So, Windows, the command is ARP-A. Okay? So, specifically, ARP cache had a mapping that's that said, let's say, kunwari, meron kang MAC address na 22222 and so on. Okay? Diyan hinahanap ng router natin yung mapping na yun. Kasi we need to have two addresses para makamove yung information natin from point A to point B. So, those two addresses would be your IP address and as well as the hardware address. So, what are the sources of routing information? Yung router natin can be populated ng multiple sources. Pwedeng dynamic routing, OSPF, EIGRP, RIP, okay, BGP, okay. For older ones, you have the EGP and as well as yung IGRP natin. Also, the router is physically attached to the network. What does that mean? Connected siya. Okay, you as administrators, we add the networks do sa mga interfaces na yun. Also, the static route. Administrator, kayo add the static route dun sa iyong router. Okay, that can be done as well. Now, what are directly connected routes? One way for a router to know how to reach a specific destination network is by virtue of the fact that the router has an interface directly participating dun sa network na yun. Okay? So, what does that mean? Alright. So, let's say, kunwari, you currently have a router in place. Okay? You have a router in place And okay, let me just show you. So I'll just do some um, good links here. Okay. So let's say you currently have a router in place, right? And it's currently connected to your network. Maybe a switch there. So this interface that you have here directly participates. Kunwari, ang IP address is 192.168, okay, .1.1. So that IP address that we have here, okay, that is part of your network. It directly participates onto it. Di ba? So alam niya kagad na, hey, I know this network. This is actually connected to me. Right? So, yun lang sinasabi dito na by the virtue of the fact that the router has an interface directly participating in that network. Right? So, yan yung isang advantage of using directly connected networks. Kasi kanya na kagad yun. Okay? So, next, let's talk about static routes as well. Okay? So, what are static routes? Okay? Routes can also be statically configured sa ating routing table. Okay? Kailangan lang siya, manual mo siyang ilalagay doon, which is pag kunwari, let's say around 5, 6, 7 entries, that's basically easy, right? But what if you currently need about 10 or more than 10, 11, 15, 100 networks? Kailangan mo siyang i-type in one by one. Okay? So medyo may exercise yung mga fingers mo when using when you're keying in those static routes. Kind of crazy kasi ang dami na nga niya, 'di ba? Also, kadalasan naman kasi sa network natin, we also add a static route onto it every now and then. Okay? But nonetheless, if you currently have like a lot of networks to be added to sa ating router, there are several options. Like you could use a dynamic routing protocol, or you could summarize the routes. Like kunwari, if you have like a /24, 5/24 networks, di ba? Pwede mo naman siyang summarize into like isang /20 na lang to cover that network. Okay? So, yun yung mga options mo para hindi masyadong maraming entries yung ating routing table. We wanted the routing table to be, as much as possible, lesser entries ang nando sa routing table natin. Kasi pag sobrang dami rin ng entries natin, medyo nabubulunan yung router. Yung processes niya dumadami. Kasi it's a lookup. So, hahanapin niya yun one by one, right? And we don't want that to happen. One by one, hinahanap niya. So, you could actually just simply summarize the routes first. That's part of your network design. Mas matikas ang network natin pag nasa-summarize natin yung information, yung mga routes natin. So, let's say, just the whole /20 or just the whole /16 will be routed over palabas to sa ating router. Okay? So, next is dynamic routing protocols. Alright? So, a protocol on one router communicates with the same protocol running on neighboring routers. Then, the routers update each other about all the networks they know about and place this information into the routing table. A variety of dynamic routing protocols available that allow a router's routing table to be updated as the network condition change. Okay? So, ano nga ba yung mga available na routing protocols natin? There are actually a lot. Okay? Basically, ang mga options natin would be RIP. Okay? We also have OSPF. Okay? We have BIGRP. We have BGP as well. For older ones, they have IGRP. Yung iba pa gumagamit naman ng IS, but so those are the available dynamic routing protocols that we have. Okay. Later on, we'll try to go in depth regarding this more dynamic routing protocols that are available. Okay. So, by the way, what about believability of the route? Okay. we call that believability of the route as admin distance. So if you hear the terminology administrative distance, okay, that is the believability of the route. Okay, some routing protocols are considered mas kapani-paniwala versus dun sa iba. Okay, so the first off is the directly connected networks. Okay, syempre connected to sa'yo yan, right? So since connected to sa'yo, zero dapat ang ating admin distance. And just to let you know guys, admin distance, the lower is always better for admin distance natin. Next are statically configured networks, right? Syempre, kung statically configured siya, you manually hand type it, right? So, yung routers natin, na-assume niya na alam nung network administrator yung ginagawa niya. Okay. We also have EIGRP, which is Cisco proprietary, OSPF, RIP. Okay, so paano naman nangyayari yung believability ng routes natin? Okay, so let's say you currently need to go to 192.168, okay, .1.0 slash 24. Okay, so this one came from, let's say, this one is from EIGRP. Okay, and then another route mula naman sa RIP, okay, would be 192.168, okay, .1.0 slash, let's say, 25. Okay, so sinong paniniwalaan ng router natin dito? Basically, pagka ganito ang scenario natin, mas paniniwalaan pa rin ang RIP. Okay? So, bakit paniniwalaan ang RIP? Alright. So, going back. Okay? Going back sa ating first principle of routing. Okay? Sa routing principle, best match is the route that has the longest or the longer prefix. A route entry with the longer prefix is the most specific. Okay? So basically, dito sa scenario na to, mas paniniwalaan ng router yung RIP. Okay? This actually changes, okay? Kung let's say yung RIP entry mo would be also a slash 24. Okay? That's the time where admin distance comes in. Okay? So by this time, ang pipiliin na ng router natin would be EIGRP. Okay. Now, what if tabla-tabla pa rin? Okay, so let's say kunwari, nagtabla tong dalawa na to. They have the same admin distance, okay? They have the same prefix match, parehas. Slash 24 pareho, kunwari. And then you have the same admin distance, okay? The next thing na pagtatalo na ng ating ng router, okay, to get to point B, okay, would be what we call the metrics. Okay, so let me just define metrics. It's a value assigned to a route. The lower metrics are preferred over higher metrics. If a routing protocol knows more than one route to reach a destination network and those routes have equal metrics, some routing protocols support load balancing across equal cost paths. I believe RIP, OSPF, and as well as EIGRP actually supports load balancing. That's equal load balancing siya. That means na kung parehas siya talaga, parehas ng metrics, parehas in everything, maglo-load balance siya across those links. But only EIGRP has the capacity na mag-perform ng unequal cost load balancing. Okay? So kayang-kaya ng EIGRP yan. But the other routing protocols doesn't have that capability. Okay, so let's talk about interior versus exterior gateway protocols. Ang mga interior gateway protocols, it operates only sa ating autonomous system. Okay, so where an autonomous system, okay, is a network under a single administrative domain. Okay, so let's say kunwari, this is your cloud here. Okay, let's say this is AS 53. All right. So yung AS mo na yan, it's being controlled by a single administrative entity. So kung no-control nyo to, so within this AS, you could use an interior gateway protocol like OSPF, RIP, EIGRP. Okay, pwede kang gumamit dito sa AS53 na to. But if you would be connecting to another AS, like let's say AS54 here, okay, we have AS54. You'll be interconnecting with AS54. Hindi sila papayag na gumamit ka ng IGP to communicate with it. Okay? Instead, we need to use an exterior gateway protocol to operate between autonomous systems. So, siya yung mag-handle ng communication between AS53 and AS54. But, if you're just within AS53, okay, IGP kailangan gumamit din tayo. Okay. So let's talk about distance vector. Okay, so ang mga distance vector routers natin would be RIP. Okay, this is the prime example. Okay, so the best path to a remote network is by judging its distance. A distance vector routing protocol sends a full copy of its routing table to its directly attached neighbors, and it also supports periodic advertisement. So, paano niya ginajudge yung distance? So let's say here, okay, you have you need to go to 192.168.1.0, okay, slash like 24 here. Alright? So ito is a perspective nitong router na to. Right? So he needs to go there. Nakita niyo dito, oh, yung route na to are 3 hops away from me. Okay? So let's say there's an imaginary router here as well. Okay? And another router right over here. Okay? So, may tayong connectivity. Okay? So, dito naman sa kanya, okay, there would be 1, 2, 3. So, sa perspective niya, the route is actually 3 hops away naman. Okay, so this router would prefer this route, okay, rather than using the other one because sa perspective niya, oh, tatlong hops doon, samantalang dito tatlo lang. I mean, dalawa lang. So I would prefer this, sabihin niya ganun, okay? So ang issue doon is that what if the links that you currently have here are just only 1 megabit, okay? 1 megabit lang siya, okay? But on this router, the other router that we have here, I mean the other path that we have here, it has 100. Okay? So see, meron na tayong issue dito. Your router would still prefer to use this route kasi yun ang naiisip niyang mas malapit as compared dun sa mas matataas yung bandwidth natin. Okay? So, yan ang hindi kino-compute ng RIP. The bandwidth, hindi part kasi ng metric niya yun. Ang metric niya lang would be the number of hops. Okay? Also, yung RIP natin, wala siyang idea, okay, yung total view ng network. So, ang alam niya lang is yung neighbor niya. Ang sinasabi kasi doon, stated doon sa kanyang routing table na this one was passed along by my neighbor. So, doon lang siya tatalon. And then, itong neighbor na to, siya naman yung magpapasa dito sa router na to. Also, another thing about it is that periodic ang advertisement. So, even though the routers already learned about that certain route, ang gagawin niya doon is that ipa-flush niya lang yun and then i-add niya ulit sa kanyang routing table. Right? As compared sa EIGRP or sa OSPF, once na nagkaroon ka ng update, that's the only time that it would trigger the advertisement. Okay? Next are what we call link state routing protocols. Yung link state routing protocol naman natin, these routers send out link state advertisements sa networks that alam nila kung paano nila ma-reach. Okay? Routers then use those LSAs to construct a topological map of a network. We're using the Dijkstra algorithm, the shortest path first algorithm, para mabuo natin yung ating network. So parang ang link state naman natin is like you're building a map of a country. Right? So yung country na yun, ito yung mga places to go in that country. okay, malalaman ng router yun via link state advertisements. Okay? So, let's talk about some of the routing protocols. Alright? So, the first one is what we call routing information protocol, or RIP. It's a distance vector routing protocol that uses a metric of hop count. The maximum number of hops between two routers in a RIP-based network is just 15. A hop count of 16 considered na infinite. Okay, so kunwari, hindi nila ma-reach a certain network. Okay, so let's say we have three routers here. Tapos, itong so we currently have three routers. Tapos, what happened was, this network went down. It went down, so it's no longer reachable. Dito kay router B, okay, itatag niya yung route na yon as 16. Okay? A hop count of 16. Alright? So that means na hindi na reachable yung ating network. So, itong si A, okay, nakikita niyo, 16 yung hop count. So definitely, hindi siya reachable via web. Okay. The next one is what we call open shortest path first. Link state routing protocol that uses a metric of cost, which is based sa link speed natin, yung bandwidth natin. So, kino-compute ng RIP natin. Kunwari, ang link natin is only 10 megabits per second. Uses 100 megabits per second. The other one is 1 gigabit per second. I-prefer niya yung may pinaka mataas na bandwidth. Okay? Ang isa pang kainaman sa RIP is that it's very scalable. Okay? Mabilis ang convergence niya kasi nga triggered lang yung updates. Once na fully established na yung network mo, triggered na yung updates niya. And of course, it's vendor interoperable. So maraming vendors compatible with or they have OSPF as part of the routing protocol suite ng kanilang product. Okay. So, meron din tayong tinatawag na IS-IS or intermediate system to intermediate system. Basically, yung IS-IS na to is very similar sa OSPF. As far as I know, you configure this on the interface level. It also uses Dijkstra's algorithm to compute sa ating OSPF, Dijkstra algorithm para dun sa ating, para mabuo niya yung kanyang routing table. Basically, this ISIS most of the time is being used by service providers and not really being used on some IGPs. To be honest, I haven't encountered such. It's not really that widely deployed as compared to OSPF. So, but basically, of course, there would be networks that uses IS for that. Okay. Now let's talk about EIGRP or Enhanced Interior Gateway Routing Protocol. Cisco proprietary siya, so it's only Cisco that if you have a Cisco device, you may be able to use EIGRP. Though sa ngayon, what Cisco did was they actually tried to open it to everyone. So every vendor pwede na silang maglagay ng EI or they could have EIGRP sa kanilang mga routers. Okay, so what are the advantages we have for EIGRP? So it supports IP and IPv6. It's classless. Okay. Also, it supports BLSM and CIDR. Supports summary and discontiguous network. Maganda yung kanyang label discovery. Yung communication is by what we call reliable transfer protocol, and it uses the algorithm diffusing update. So yung OSPF natin, it uses Dijkstra. ISIS natin, it uses Dijkstra as well. Yung RIP natin, it uses the Bellman-Ford algorithm. Sa RIP, okay, it uses diffusing update algorithm naman. Okay. So, what about BGP? BGP, yan ang nagpapatakbo ng ating internet. Basically, yung networks natin, the service providers, they're actually interconnected with one another. Okay? Since it's actually interconnected, what would happen there is that BGP is the one that actually shows yung connectivity between the service provider A, service provider B, or certain institutions and enterprises that uses BGP as well. It's actually considered more of a reachability protocol rather than a routing protocol. So, paano reachability? So, just in case you have this, you have your router, okay, and then you currently have two service providers, okay. So, see service provider A, service provider B, okay, and you currently advertising a prefix list, okay. I mean a prefix, sorry, 110.63.4.0. Okay, this is a public address, and you want this to be reached sa internet. So sabihin natin, this is my primary link, okay, para ma-advertise ko to, okay. But all of a sudden, it went down. This link went down. So here comes service provider B taking over. Mangyayari is that yung mga routes, okay, yung prefix na to would now be advertised towards service provider B. Okay. So dito naman po natin ang ating BGP advertises, learns, and chooses the best path inside the global internet. When two ISPs connect, typically they use BGP to exchange routing information. ISPs of the world exchange the internet's routing table using BGP, and as well as yung mga enterprises or institutions. One key difference when comparing BGP to the usual IGP routing protocols that BGP's robust best path algorithm. BGP uses this algorithm to choose the best BGP path using rules that extend far beyond choosing the route with the lowest metric. So, ang tawag natin doon are what we call path attributes. So now, we will be ending up our discussion regarding this ating mga routing protocols, and we will proceed with network address translation. Okay? So ano ba ang ginagawa ng ating network address translation? Ilang IP addresses are not routable sa ating internet. Okay? So hindi siya pwedeng gamitin. Some of the examples that we have is 10.0.0, okay, .0 /8, hindi natin pwedeng gamitin sa internet to. 172.16 .0.0, okay, hindi mo rin siya pwedeng gamitin sa internet, okay. This is I believe /16 for this, okay. And we also have 192.168, okay, .0.0, okay, hanggang 192.168.255.255. Hindi mo rin siya pwedeng gamitin sa ating internet. Those are considered private addresses, okay? If you want to take a look, it's currently, I believe, RFC 1918 para sa ating mga private addresses, okay? So, some IP addresses are routable to the public internet, while other addresses are considered private and are intended for use within an organization. Yung NAT natin, okay, allows those private addresses as defined sa ating RFC 1918 to be translated sa internet routable public address. Okay, so kailan tayo gumagamit ng NAT? Alright, so first off, pwede kang multiple multiple private addresses that you have. Pwede mo siyang gamitin, okay? Pwede mo siyang gamitin, like, kunwari, sa bahay mo, di ba? You have a lot of those devices that you currently have at home, right? But basically, isang IP address na ang pinoprovide sa atin ng service provider. Okay? So, ang ginagawa ng ating routers that minumultiplex niya on that IP address yung mga kailangan nating puntahan. Okay? That's one of the things that your router does to perform NAT. Okay? Another one is, kunwari, may mga servers ka, and basically, yung hassle na papalit-palitan mo yung IP address nila to a public address, and then you change it to let's say, palit ka ng service provider, you have to remove those public addresses, you need to add a new one, right? Galing dito sa bago mong service provider. I mean, it's kinda odd, right? Instead, you could use NAT. Gawa mo lang ng mapping yan sa iyong router. So if in case you're changing service providers, hindi mo na kailangan pakialaman yung mga computers. You just have to focus on the router, change the IP address. Also, we have the mergers. Got it. You have two companies with the same network range. Let's say gumagamit sila ng 192.168.1.1 or I mean .1.0/94. The other company uses the same range, 192.168.1.0/24. Pag pinag-merge mo sila, of course, there would be conflicts that would happen, right? So instead, what we could do, we could add a NAT router in the very middle. That, let's say, kunwari, access ka sa resources ni company A, yung IP address niya would become 192.168.100.1 or 192.168.100.2. But physically, you haven't changed anything. Any IP addresses here on the inside, hindi natin pinapalitan. Yung router lang natin, nagpe-perform lang siya ng translation. Okay, so these are the most common NAT options that we have. The first one is what we call the static NAT, one-to-one mapping yan between local and global addresses. Okay. Next one is what we call the dynamic NAT, map of an unregistered IP to a registered IP from out of a pool. Okay, and then we also have overloading, which permit users to connect to the internet using one IP. Okay, so sa static NAT natin, okay, so let's say I'll just go here. Okay, this is your router. Tapos itong router mo connected siya sa isang server, right? So ang gagawin mo dito is that let's say yung IP address ng server mo is 10.1.1.3, okay? Ang gagawin ng router natin is that, okay, so ang entry ko dito would become, let's say, 50.1.16.3, okay? Yung router mo, pwede niyang i-map yun dun sa private IP address na yan. May capability yung router natin to do that as well, okay? Now, let's say, kunwari, meron tayong isang user dito. Okay, may user tayo dito somewhere. Say VPN user siya. Or, let's say, just, you just wanted to access your resources dun sa ating internet. Okay? So, ating cloud. Okay? May cloud tayo dyan. And of course, your router is connected to that cloud as well. Right? So, let's say, gusto kong i-access yung resources ni 50.1.16.3. So, basically, what will happen here is that pupuntahan niya tong site na to. Right? And that will end up on your router. So, 50.1.63 mag-end up to sa router mo yan. Pag nag-end up siya to sa router natin, okay, itong router natin, naiintindihan niya na, meron akong mapping dito. So, 50.1.16.3 is actually mapped towards 10.1.1.3. So, itong router natin would then again forward the request or the packets, forward na yun doon sa ating server. Okay? So, basically, forward na yun doon sa server mo. And you don't really have to perform any changes sa ating server. Yung nating na to, yung NAT, is totally transparent doon sa ating mga servers. Okay? That's one of the advantages that we have of using a static NAT. But mind you, pagka ginawa mo kasi itong mapping na to, yung static NAT mapping natin na yan, okay, it if you actually perform this mapping, ang mangyayari dito is that this IP address that you have here is already mapped dito sa address na to. Okay? So, you won't be able to use 50.1.16.3, let's say, on another server here. Hindi mo na siya pwedeng gawin. Okay? Instead, dito lang siya nakamap. So, yung mga services lang nitong server na to, ang pwede mong ma-access via 50.1.16.3. Okay. So, kunwari, HTTP, accessible siya. Right? So, what happened was, yung home user natin dito or somebody using the machine, in-access niya yung keyed in HTTP 50.1.16.3 sa web browser niya. So, mag-end up yun dito sa server mo na to. Okay? Next is FTP. Kunwari, in-FTP niya. Okay? Mag-end up din yun. Yan, mag-end up din yan dito sa server mo na to. Another one is like, let's say, SSH. Diyan din siya mag-end up sa server na yan. Kasi, meron ka ng static mapping. From 50.1.16.3 papunta kay 10.1.1.3. Of course, the disadvantage that you have there is that dun lang sa server na yun, lahat ng request mo mapupunta lang dun sa server na yun. Yan ang isang disadvantage nito. Okay? Instead of, you could just create port forwards, right? What happened was, static yung map mo. 1:1 siya. Diba? Sayang naman kasi yung ibang services mo available din. Let's say, kunwari, sa isang router, you just wanted to use HTTP on it or web server lang siya. So, HTTP lang siya doon. Yun yung navigation niya. The other one's your FTP server, so you can just open the port and point it towards that IP address. Right? Yan ang isang disadvantage ng static net. Since 1:1 siya, lahat ng services, doon lang sa server na yun, mapupunta. Okay. Now, we also have what we call the dynamic netting naman, okay? So, what it does is that yung sa router mo, okay? Yung router mo na to, meron siyang current pool ng IP address. So, ano ba yung pool? Pool lang siya. So, let's say, ang pool ng IP address ko dito on this router is like, say, 50.1.16.1, okay, until 50, okay, .1.16.5, okay? So, pag may kailangan gumamit kung pool na to, okay? So, let's say, ito yung network mo, and there's like 10.1.1.16, okay? Gusto siyang lumabas sa internet, okay? You could actually create a dynamic netting or dynamic net entry dito sa router na to. Okay? So what would happen here is that yung 10.1.1.16, okay, ang gagawin ng router is that, hey, okay, available yung 50.1.16.1, so that would be what you would use to go out. Okay? So yun. Next, let's say kunwari meron ka namang IP address 10.1.1.17 naman siya, di ba? Okay, kailangan niya rin umaccess ng internet. Ang gagawin naman ng router natin, since 50.1.16.1 is already being used, lilipat naman siya sa 50.1.16.2 naman. Okay? Pagkatapos gamitin, let's say kunwari, 10.1.1.16, tapos siya nang gamitin yung nakapag-internet na siya and everything. What it would do is that it would actually close or terminate na ng router natin yung session niya na yun, and then ibabalik niya, i-recover niya yung 50.1.16.1 IP, ibabalik niya yung sa pool para magamit naman ng ibang mga devices natin or ng ibang mga devices na eventually gagamit ng ating IP address, okay, papunta sa internet. Okay. So, meron siyang certain pool doon, i-write off niya pagka ginagamit, and then ibabalik niya once tapos ng gamitin. Okay? Now, let's talk about overloading. So, permit users to connect to the internet using one global IP. So, basically, yung mga routers natin, kunwari, bibili tayo ng router sa CDR King or bibili tayo ng mod, bibili tayo ng router. Most of the time, ang ginagawa ng router na yon is we call NAT overload. Okay? So, isang IP lang ito provide sa atin, like, kunwari, yung mga service providers natin dito, PLDT, Smart, Globe, and everyone else, Firetel, they would provide you with a one public IP address, one public, okay, one public, okay, but okay, you actually share that one public IP to your multiple devices at home. So, syempre, sa bahay mo, definitely you have one computer, one tablet, one cell phone, right? And everybody would use the internet all at the same time. Okay? Definitely, hindi nila ginagamit yun one by one. Okay? Instead, your router would assign a certain port, okay, para dun sa specific na session na yon. And then, tsaka niya i-accessin kung saan mo man gustong pumunta. Okay? So, this one public address that we have here is being shared among multiple devices sa ating network. Basically, this is the most common NAT na ginagamit natin. Kasi kahit yung mga routers, I mean, yung mga normal na router, I mean, what we could say is that, as long as, parang pag sinabi nating router, ang i-expect natin is that mag-perform ng overloading function. But definitely, that's one of the functions that you have para dyan sa router na yan. But not the main function ng ating router. Because the main function of the router, of course, is the forward traffic. Pagka lang naman, gumagamit tayo or pang internet natin yung router na yun, that's the time that you actually need yung ating overloading. Okay? But the router itself, it doesn't really have to overload lahat ng network natin. Kasi syempre, sometimes we have VPN services, right? Like in the office, right? We don't overload the IP address. Ina-advertise natin yung mga private addresses kasi nga, nandun naman siya with the same network. So, ina-advertise natin yun. We don't overload. Ang pag-overload lang, ginagawa lang yan pag gusto mong umaccess ng internet natin. So, access ka ng internet, bibigyan ka ng service provider mo ng isang public IP address, paghahati-hatian na yan ng mga devices natin like the tablet, the cell phone, okay, the computer, right? So, lahat sila, ito, kahit naka-private link sila, they could utilize that one public address that was provided ng iyong service provider. Also, another thing about overloading is that it uses ports, okay, para mai-multiplex niya yung multiple devices mo dito. Kaya the other name that we have for overloading is what we call port address translation. Ang claim nila doon is that it's Microsoft who invented the terminology port address translation. Kasi nga, yung router mo, meron siyang mga ports doon, okay, from 1 to 65,000, yun yung gagamitin niya. Okay? So, let's say you need to go to Google. Ito, gamitin mo itong port 992. You'll go to Facebook. Nagamit siya ng port 992. One of the devices goes to Google Play Store. This is port 994. Okay? Once done, ma-remove na yung port ko na yun. Okay? And ibabalik niya ito sa pool na pwedeng gamitin ng router natin. Okay? So, that is what we call port address translation or NAT overloading. Okay. So let's just try to go back to our to the things that we have discussed. Okay, let's have some summary. Okay, so basic routing process natin. You can have our router relies on the routing table. Okay, para makapag-route siya. Okay, yan ang pinukonsulta niya para makapag-route siya. Routing principles, number 1, okay, would be the longest match or longest prefix to sa ating routing table. Okay. The second, okay, would be our admin distance. Okay. The third one is the metric. Ito yung ating ARP cache. Okay? Yung mga routers natin, they have this. Okay? Meron yung mga routers natin ito. And as well as yung ating mga host devices. So it's layer 3 to layer 2 mapping. We call it the ARP or address resolution. So some of the sources of routing information would be, it can be learned by a dynamic routing, physically attach yung router natin or connected network siya, and as well as the static route. So directly connected routes, yun yung mga IP address na ina-assign natin directly sa mga routers. Okay? Static route, hand-type na network location siya. Next is the dynamic routing protocol. Yan yung like you're using OSPF, EIGRP, or RIP sa iyong autonomous system. Believability of the route is what we call the admin distance. Okay? And cada routing protocol, they have an admin distance. Okay? Next is the metric. The lowest metric, we have a routing protocol, it has a metric. The lower metric is always preferred on any routing protocol. IGP operates within the autonomous system. Yung EGP natin operates between autonomous systems. Distance vector uses hop count, okay, to determine distance. Ang link state natin is like a jigsaw puzzle ng ating mapa. Okay? And once you have received all of the jigsaw puzzle, alright, bubuo mo na yung picture ng let's say ng Philippines or whatever country, okay, para makapag-route ka. Okay, so we talked about RIP, hop count, ang kanyang metric. OSPF uses cost, okay, yung bandwidth ng link ang importante. Okay, ISIS, similar siya sa OSPF, pero hindi siya masyadong before. Next is EIGRP, used to be Cisco proprietary, now it's open standard. We also have BGP, this is the routing protocol of the internet. So we talked about network address translation, okay? So, yung ibang network natin, if you want to reach them, okay, you may have to use NAT. So, kailan yun? So, multiple vendors, or multiple private IP addresses that we have, okay, represented by a smaller number of public addresses. Kung may migration, you could use NAT, mergers, and load sharing ng ating mga servers. Oops. We also have static NAT. Basically, this is 1:1 mapping ng ating IP address. Dynamic NAT, multiple pools ng public addresses versus multiple pools ng private addresses. Overloading one public address to be used by all of our devices. And this ends up our session. Okay. If you have any questions, you can send an email to mamaddelrosario@gmail.com. You have a good day. Bye.